Hello, students. So this video here, this lesson is on reflections and dilations with function notation. Again, guys, we've done previous videos, or we've done a previous video that was just kind of an introduction to transformations, where we explained exactly what a reflection is and what a dilation is. And again, a reflection is a transformation where it's sort of like a flipping over or about a certain line. So it's a flipping over or about a vertical, horizontal, or diagonal line, and it flips. The figure flips in such a way that your pre-image and your image are equidistant from that line of reflection. And a dilation, guys, again is a type of transformation that stretches or shrinks, or in other words, it is a type of transformation that either enlarges, makes it get bigger, or reduces, makes it get smaller. It usually, with dilations, there's a center of dilation, and again, there's a certain scale factor as well. But anyway, we had made a previous video that kind of went through certain basic features and properties of these. And really, we didn't even go into that much detail with the basic features of them. But anyway, so guys, before we get into the whole function notation part with this, again, let me just remind you that when we are using function notation, there's a difference. There's a difference between when there's a change that's happening inside the function and when there's a change that's happening outside of the function. Remember, guys, that those changes inside the function are going to be horizontal changes, and those changes that occur outside of the function are going to be vertical changes. So, guys, do you remember all of these things from previous lessons? Exactly what a reflection is, exactly what a dilation is. Do you remember those very important FYIs that I gave you during one of the previous lessons? And again, the fact that we had said that all of the changes that happen inside of the function are horizontal, all of the changes that happen outside of the function are vertical. And again, we said that those vertical changes are straightforward and as you would expect them to be, and the horizontal changes are counterintuitive and not really as expected. The horizontal changes are sort of the opposite of the way that you would expect them to be. So again, before we jump into function notation, please make sure that you remember these things from the previous lessons, because again, it's important. Okay, so folks, if you remember these things, then we can move on and talk about again the function notation that you would expect to see when you're dealing with reflections and dilations. In the very latest video, or in the most recent video that and lesson that we had yesterday on translations, guys, remember for translations, the function notation for translations was based on you adding or subtracting a number, and again, so translations was based on you adding or subtracting a number. either inside of the function or outside of the function, right? Or you know, or possibly both, right? So when there's numbers added or subtracted inside of the or outside of the function, then that's specifically only a translation that's happening there. Okay, and so that's sort of what we're going to focus on first. Really, what's the difference between when you're doing translations and when you're doing a reflection or a dilation, right? So again, guys, with translations, that was where you were adding and subtracting numbers either inside or outside of the function. And guys, for both reflections and dilations, that part there, or that transformation, is really only happening when you're multiplying some type of numbers, either inside or outside of the function. So again, it's the difference between adding and subtracting numbers or multiplying numbers, okay? Okay, so again, guys, there's a major difference between when we're adding and subtracting with function notation and when we're multiplying and dividing with function notation. As we had already mentioned before, guys, when we're adding and subtracting with function notation, that is going to be what represents your translations, shifting left, right, up, and down. And we've talked about that already in a previous lesson. But again, the part that we have not talked about yet is when we're multiplying with function notation. And again, depending on whether or not it's positive or negative, also depending on I guess the size of the number, it could represent a reflection or dilation when we're multiplying with function notations. But again, so in this lesson here, we're going to take a closer look at these notations here on the right side, where we're multiplying with function notation. And again, and this is right now what you see written is just sort of like a little general type of form for how that can sort of look. But again, I haven't really explained anything specific yet, so don't get too carried away with what you see, because I haven't explained exactly when it is that there's going to be a reflection, or when it is that you expect to see dilations. And again, there's different types of reflections. There's vertical ones, there's horizontal ones, and again, and there's different types of dilations. Remember, not only are there vertical dilations, there's also horizontal dilations, and on top of that, the dilation can be either a stretch or enlargement, or it can be a shrinking or a reduce or reduction. You know. So again, there's kind of a lot that we need to kind of go into, or at least enough, maybe not a lot, but enough for us to go into with this. And in this particular video here, I'm not really going to do a lot of examples. I may do one or two just to make my point of with exactly how this is supposed to look. But again, we're going to look closer at this multiplying with the function notation, and look at when it is that we'll have reflections and when it is that we'll have dilations, and what types of reflections we can have, what types of dilations we can have, right? So we're going to delve deeper into that. Okay, so you guys may be wondering and may be asking yourself, or you might be saying, okay, Mr. Starkey, so when exactly will there be a reflection? And when will there be a dilation? You know what? I'm glad y'all asked. That's a good question. So there will only be a reflection when that number that's being multiplied either inside of the function or outside of the function, but again, when the number that's being multiplied is negative. So again, guys, there will only be a reflection if the number that's being multiplied either on the inside or on the outside of the function, if that number being multiplied is negative. So once more, folks, there will only be a reflection if the number being multiplied is negative, either inside the function, like what you see here with this b times the x, or it could be outside the function, like what you see here with this a times the f of x. Okay? All right, so that's when there will be a reflection, guys. There will only be a dilation. There'll only be a dilation if the number that's being multiplied either inside or outside. But again, if that number that is being multiplied is not, and I repeat, is not 1. Okay? So in other words, that number that's being multiplied, it's only a dilation if that number that's being multiplied is any other number besides 1. Any other number. If the absolute value of that number is anything other than 1, then it is a dilation. But again, so it's only a dilation if that number, or if the absolute value of that number that's being multiplied is not 1. Now, absolute value, folks, remember that the absolute value, no matter what number you take the absolute value of, it's going to be a positive result. Because again, when we say absolute value, we're really talking about the distance of that number away from 0. And again, guys, if we're talking about the distance of a number away from 0, distance is always positive. So again, if we're talking about absolute value of positive 8 is 8, and the absolute value of negative 8 is 8, right? Because for negative 8 and for positive 8, they both have the same distance away from 0, and that distance is going to be a positive number, 8, right? Anyway, but back to this, right? So when will there be a dilation? There's only going to be a dilation if the absolute value of the number that's being multiplied is not 1. Okay? And so again, it could be the number that's multiplied inside of the function, or it could be the number that's multiplied outside of the function, but only if the absolute value of that number being multiplied is not 1. All right, so again, guys, there's only going to be a dilation if the absolute value of the number being multiplied is not 1. And again, guys, for those who are still confused when I'm saying if the absolute value of the number is not 1, think of it like this, guys. So regardless of whether the number is positive or negative, regardless of whether you have a positive or negative number, the number that's there cannot be a 1. It can be any other number, positive or negative, but it cannot be 1. Okay? That's what I mean. Okay, So let's go a little bit deeper. So why can a dilation be any other number except 1? Right? Think about it. So we're saying that you're multiplying this thing times some number, right? Think about what happens if you multiply a value times 1, right? What happens to that value if you multiply it times 1? Is it going to change, or is it going to stay the same? If you multiply something times 1, right? Think about it. Think about if we have the value 3, right? What's going to happen to that value of 3 if we multiply it times 1? Absolutely nothing, right? If we multiply any value times 1, it's not going to get smaller and it's not going to get bigger, right? So the only time that a value is going to get smaller or bigger is if we multiply it times some number that is not 1. I do hope that makes sense to you guys, right? You should know that when you multiply any number times 1, that it stays the same. Okay? And if it stays the same, it cannot be a dilation. If it stays the same size, it can't be a dilation. So again, that's why it's only a dilation if you're multiplying it times some number, any number, where the absolute value of that number is not 1. Because again, multiplying something times 1 will not cause the value to grow or diminish. It will not cause the value to stretch or shrink. It will not cause the value to get bigger or smaller if you multiply it times 1. Okay, so here, written in green, in the color green, I just wanted to show you guys really briefly, just again, what happens if you do multiply a function times the number 1. Again, guys, for both of these, I've just multiplied the outside of the function times 1. Again, this first one where you just have f of x, it's understood that there's a 1 being multiplied times that, even if the 1 is not visible and not written there, it's understood that it's a 1 that's being multiplied times that. And if that's the case, if there is a 1 that's being multiplied by that, it's the same thing as if the 1 was not written. It's just the same thing as f of x. So there's no transformation there when it gets multiplied by 1. And then if it did say negative f of x, and again if the negative was on the outside, that's the same thing as it being multiplied by negative 1, right? Again, guys, because it's being multiplied by 1, the value itself doesn't get bigger or smaller. The value just changes signs. Like for instance, if that value was positive 3, again, positive 3, if you multiplied it by negative 1, the actual absolute value of that number wouldn't change. The value would just become the opposite sign. But it wouldn't be bigger or smaller than 3. It would just become a negative 3. So, but anyway, if you're multiplying it by a negative number, even if that's a negative 1, then there will be a reflection because you're multiplying times a negative number. But again, because that number is 1, there will be no dilation. Again, folks, whether it's positive 1 that you're multiplying it by, or whether it's negative 1, there will be no dilation. In order for it to be a dilation, it has to be any other number besides 1. Hopefully that helps clear things up. Okay, you might say that I'm over explaining, but I hope that helped clear things up for you. Uh, Again, folks, when you're multiplying a negative number on the outside of your function, like what you see here with the negative a times the f of x, again, that's going to be a vertical reflection. And again, guys, when we say vertical reflection, we're talking about specifically, we're talking about reflecting over or about the x-axis. Again, you should know what the x-axis is, and again, that's that axis that's going left and right. But again, when we say a vertical reflection, we're talking about reflecting over or about the x-axis. Okay, and then for horizontal reflections, if you're multiplying a negative number times x on the inside of the function, then it's going to be a horizontal reflection. And again, when we say horizontal reflection, we are referring to, and specifically we are talking about reflecting over or about the y-axis. Okay, so guys, with dilations, not only do we need to consider whether or not we're talking about a vertical dilation or a horizontal dilation, but we also need to distinguish whether or not we're talking about a vertical stretch or a vertical shrink, and again, if it is horizontal, whether or not we're talking about a horizontal stretch or a horizontal shrink. Okay, so guys, remember that it will be a vertical dilation if you're multiplying a number on the outside of f of x. And again, it'll particularly and specifically be a vertical stretch if the absolute value of that number, if the absolute value of that number is bigger than 1. Guys, remember that when you're doing the absolute value of numbers, like for instance, the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. So again, guys, if the absolute value of whatever that number is, if that absolute value is bigger than 1, then it's going to be a vertical stretch. Okay? And then on the other side, on the flip side of that, it'll be a vertical shrink, guys, if the absolute value of that a, or of that number being multiplied outside, if the absolute value of that number is smaller than 1, then it's going to be a vertical shrink. Okay? So again, guys, for horizontal dilations, it's only going to be a horizontal dilation if you're multiplying some number on the inside of the function. Multiplying some number on the inside of the function, and that's that b that you see right there, being multiplied times x on the inside of the function. So guys, again, it'll be a horizontal stretch. It'll be a horizontal stretch if the absolute value of that number is the absolute value of b, that number multiplied on the inside. It'll be a horizontal stretch if the absolute value of that number is less than 1. Again, guys, I know that seems kind of hard. That seems a little counterintuitive. Yeah. Remember that we said that when you have those horizontal changes, those changes happening inside the function, that they're going to sort of seem to be counterintuitive. Yeah, it's counterintuitive for you to multiply times a number that's less than 1. Multiplying it times a number that's less than 1, like right here in this picture, you see that is multiplied by 1/2. Yet, guys, multiplying it by 1/2 on the inside of this function is a horizontal stretch. Yeah, again, it's counterintuitive. It goes against the natural grain of things, of how you would normally expect it to do. But again, yeah, that's that. So again, it's a horizontal dilation, it's a horizontal stretch if the absolute value of that number that's being multiplied on the inside of the function is less than 1. And then on the flip side of that, guys, it is a horizontal shrink if the absolute value of that number that's being multiplied on the inside of the function is bigger than 1. Okay? Guys, that's it. Yeah. So again, guys, I realized that in this particular video, we didn't go over any like specific, like actual examples where you could actually see what these functions look like. The closest thing that you got to an example here in this particular video lesson is these pictures that I'm showing you right here. But again, for your lesson tomorrow, we will go over more examples where you're actually seeing equations with using those parent functions and the function notation. But yeah, in this video we just kind of wanted to explain really how to determine whether or not you're going to have dilation or a reflection, and if you can determine whether or not it's going to be a dilation or reflection, then we also wanted you to be able to determine whether or not it's going to be a reflection over the x-axis or a reflection over the y-axis, like what we showed you here. So we want you to be able to tell whether or not it's a reflection over the x-axis or a reflection over the y-axis, and we want you to be able to tell whether or not it's going to be a vertical stretch or vertical shrink if it's a dilation and it's vertical. And we also want you to be able to tell whether or not it's a horizontal stretch or a horizontal shrink. Again, so yeah. So guys, that's it. I hope that this video has been helpful with, and like I said, it may seem abstract to you right now, but again, guys, that's it for right now as far as this basic the basic form of these function notations, yeah, for reflections and dilations. That's all, folks. It's late. We got to upload these videos, and then got more work to do after that. Good night.